Now that we finished part 1 of proof 7, we measured the pi circumference of a 1 meter, 1,000 millimeter diameter circle and discovered that it was 3,144.6 millimeters. We're going to do, part 2 is math. We're going to do the math proof right here on the same big yellow circle. First thing we want to do for this big yellow circle is declare, since it's a math proof, that the circumference of this big yellow circle is 8 units, just a given 8 units. We already have the axis, the x-axis, k through I, k to I, and the y-axis, p to n, drawn on this circle. And what we want to do is inscribe a square inside the big yellow circle. A square we can draw from point P to I to N to K, and K to P is a square inside the circle. Second thing that we want to do with that is we want to bisect each side of the square. Bisect the side. For example, AQ diagonal cuts side of the square IN in half to produce 2 more sides, NQ and IQ, to make an octagon all the way around, inscribed in the big yellow circle. So we have an octagon P, T, I, Q, N, R, K, S, back to P. It's an octagon, which means that the arc from P to T on the yellow circumference, yellow circle circumference, equals the arc T to I to Q, Q to N along the curved arc, N to R, R to K, K to S, and S to P. Each arc is 1 unit of the 8 unit given circumference of the circle. The next step that we want to do is we want to transfer the length of the curved arc, for example NQ, which is curved, this arc NQ, to this diameter here as a flat line. So 2 ways we can do that. There's more than 2 ways actually. You can stick the tape measure, the engineering tape measure, back in, which we just got through doing in this cut groove, cut by the rotary circle cutter all the way around. Put the engineering tape and measure from Q to N, and then take the tape out and lay it across from A to wherever it hits. It happens to hit at D. So we've transferred the length of NQ to AD. That length is 393.075 millimeters if we were looking at millimeters. But it's 1 unit. 8 unit circumference circle. Each arc is 1 unit. Why did we want to do that? Put a straight line, 1 unit here. It's because we wanted to draw a square FHDA, back to F, 1 unit sided square, and then duplicate that at HBJD, back to H. So we have 2 squares. That forms a rectangle FBJA, back to F. And the reason we want to form a 1-1-2 sided rectangle is so we can draw the diagonal AB, and I will show you how to draw the golden ratio linear length. The golden ratio is defined as 1/2 of the square root of 5 A to M is 1/2 square root of 5. And then we drew a circle, center at M, with a radius of MC, diameter of 1, therefore 1/2. And we draw the circle all the way around here for circle M. And we have from A to C now the length of the golden ratio. As I said, it was defined as 1/2 of the square root of 5 plus 1/2. That equals 1.618033989. Next, we want to take our compass, measure from A to C, which is on this purple triangle. A to C is the golden ratio, and swing that radius AC up to hit the line FB at E, so that makes AE also equal to phi, the golden ratio. What we've just created now is the orange triangle, which is Kepler's golden ratio right triangle, with sides FA equal to 1, AE equals phi, the golden ratio, and FE, of course, equals the square root of the golden ratio. Again, using a compass, we measure F to E with a compass and drop F straight down to A, E straight down to I, and we see that FE equals AI, FE equals the square root of the golden ratio, so the radius of the big yellow circle, AI, also equals square root of the golden ratio. If the radius equals the square root of the golden ratio, then the diameter Ki equals 2 times the square root of the golden ratio. So now we have an 8-unit circumference circle divided by 2 times the square root of phi, and that will equal 4 divided by the square root of phi equals pi, and pi will equal 3.144605511. Once again, pi equals 4 divided by the square root of the golden ratio. As a curiosity, I might add that if we drew a duplicate FHDA square, 1 unit square, into this quadrant down here, and then drew another one down here, and a fourth one up here, we would have a 2-unit sided square. 4 times 2 is 8. The perimeter of that square that we would have drawn would equal the 8-unit circumference of the big yellow circle, which means we will have squared the perimeter of that square to the circumference of this circle. So if you look at my math proof 6, you can step through the method by which you can do special squaring of the sides of the Kepler golden ratio right triangle to prove, once again, pi equals 4 divided by the square root of phi, and you can carry all of those values out to 40 decimal places, and you can see that what pi really equals. So besides using an unmarked measurer, like a sheet of paper to stick into the slot of the arc in Q, we can use the original tape measure and line it up at 0 and around to see if we can zero in on this. We know it's, by calculation, 393 millimeters, 0.075. If you look closely, you can see, pan over here, 0 to 393, because you can't read 1/100th of a millimeter. You can read maybe 1/10, but it's 393 millimeters. And that can be transferred to a straight line on the diameter. So let's do that. So now we transferred the tape measure of the arc QN, which is 1 unit, up to the diameter of the circle, which is AD. And let's see if we can zero in on here. Zero all the way across to the middle and line it up. Right through the middle line is 393, essentially exactly, because it's 0.075. You can see it's $393. So what we've done is transferred the curved line UN to a straight line A to D.